SpaceX just stacked Booster 19 at record pace. But Booster 18 exploded during testing, torn apart by those same composite pressure vessels that killed Starship 36. Now SpaceX is wrapping COPVs in bright red covers and adding new inspection protocols. What did they find that changed everything? Meanwhile, China launched 88 missions in 2025 and doubled their satellite count. They're building rockets like cars on assembly lines, using pull systems that only make parts when needed. Can SpaceX's innovation beat China's industrial production? Let's find out on today's episode of New Space Review. Let me walk you through what happened with Booster 18. The teams were running routine pressure tests at Massey's facility when vapor started leaking from the chine area. You know, where those composite pressure vessels sit. Seconds later, boom! The entire section blew apart. The hole lined up exactly with where the COPVs were mounted. Main tank split wide open. Millions of dollars gone before the thing ever touched a launch pad. And here's the thing. This wasn't some random fluke. Starship 36 exploded the exact same way. Same parts, same catastrophic failure. So SpaceX had to make some hard calls. They cut the operating pressures on all COPVs across the board. Added mandatory inspections before any propellants get loaded. Completely rewrote their acceptance criteria, even developed a new testing method to catch internal damage they couldn't see before. Those bright red covers we're seeing on Booster 19 now, they're not just for show. If those covers show any impact or stress damage, the whole COPV gets yanked out, no questions asked. What SpaceX basically learned is that their pressure vessels are way more fragile than their computer models predicted. These tanks hold helium at insane pressures to push propellants into the engines. When one fails, it doesn't just leak, it detonates. The force tears through everything around it in milliseconds. That's why they built a whole dedicated testing area at Massey just for COPVs now. Every single tank goes through multiple proof tests in isolation before it even gets near a booster. Think about what this means for SpaceX's whole approach. They built their reputation on moving fast and treating failures as learning moments. But two catastrophic COPV explosions back-to-back, that crossed a line. Version 3 brings massive upgrades. A central methane downcomer as wide as a Falcon 9, a side-mounted LOX header tank for landing burns, beefed-up grid fins that work as catch points. All that engineering is worthless if a pressure tank explodes during ground testing, and the clock's ticking. Flight 12 is still scheduled for Q1 2026. Booster 19 needs cryo testing, transport to the pad, multiple wet dress rehearsals, then validate all 33 Raptor 3 engines. Ship 33 is still in the hangar getting outfitted. Orbital Mount 2 construction is ongoing with dozens of systems that can't even be tested until there's hardware on the pad. Now, here's something interesting about SpaceX's production strategy. They've built roughly 19 boosters and nearly 40 ships. Most of them never flew. People call this wasteful, but they're completely missing the point. These are production insurance. When you can crank out a booster every 3 weeks, losing one to a test failure doesn't kill your program. You've already got the next one rolling off the line. That's what separates SpaceX from old aerospace companies that treat every vehicle like it's irreplaceable. The big question now is whether they rush Booster 20 as a backup. If Booster 19 hits another problem during testing, having a relief vehicle ready could save months. but rushing B-20 might create bottlenecks down the line with B-21. There's a balance here. My read? They'll build the backup. The COPV risk is too high, and Orbital Mount 2 has too many unknowns. While SpaceX is dealing with all this, let's talk about what China's been doing. They just completed their 618th Long March launch. That's 88 missions in 2025 alone, and they're not moving this fast by luck. Traditional aerospace works on a push system. Companies forecast launch schedules months out, build components in advance, stockpile everything. Then, when launch dates slip or designs change, you've got warehouses full of parts you can't use. China looked at this and said, "No thanks." They borrowed the pull system from car manufacturing instead. Here's how it actually works. Final assembly says they need a rocket. That signal triggers engine production. Engine production triggers parts manufacturing. Parts trigger raw materials. Nothing gets built until someone downstream actually needs it. The efficiency gains are massive. No obsolete inventory sitting around, no bottlenecks from parts that don't match updated specs. Production responds to real demand, not guesses. And China didn't just adopt this system, they scaled it nationally. State companies, research institutes, private suppliers all connect through digital platforms with real-time supply chain data. Smart factories with AI and robotics can reconfigure their lines on the fly. Need to switch from Long March 5 components to commercial small satellite launchers? The factory adapts. Traditional aerospace facilities can't do that. The numbers back this up. China put 200 satellites in orbit in 2023. They doubled that in 2024. They're building Guowang and Qianfan, two massive constellations that directly challenge Starlink. They opened China's first commercial spaceport on Hainan Island. Companies like CAS Space and Landspace are launching reusable first stages this year. Startups like Cosmoleap and Yushi are building chopstick-style catch systems like Mechazilla. Brigadier General Brian Sadari from the US Space Force said it plainly last month. It is concerning how fast they've done it. China studied how America uses space for military operations, and they're building the same infrastructure. Their launch tempo jumped 30% year over year. That's not incremental progress, that's industrial transformation. Here's what most people miss. China's system solves the exact problem SpaceX faces right now. When Booster 18 exploded, SpaceX had to stop everything, investigate, redesign COPV handling, rebuild from scratch. That's the price of pushing innovation boundaries. China's pull system handles this differently. Identify the failure, implement the fix, keep producing because the system builds to current specs, not old forecasts. No backlog of potentially bad components to work through. We're watching two completely different philosophies compete. SpaceX believes in rapid iteration. Fail fast, learn from it, breakthrough innovations. China believes in systematic optimization. Take proven concepts and scale them with industrial discipline. SpaceX gave us reusable rockets. China's giving us reusable rocket factories. The question is, which philosophy wins when space shifts from experimentation to infrastructure? Look at the US commercial space sector. Multiple companies tried copying Falcon 9. Firefly, Sierra Nevada, Stoke, Relativity, Blue Origin, Virgin Orbit. Great engineering from all of them, but none reached SpaceX's scale. Why? Because any US company copying Falcon 9 immediately competes against the original. Investors see that and think, why spend hundreds of millions fighting SpaceX head-on in a market they already dominate? China's companies play a different game. Being reusable and made in China is enough to get support because it serves national strategy. The government provides easier regulations, steady funding, access to major test facilities. It's not about beating SpaceX in free market competition. It's about building space capability that doesn't depend on American launches. Completely different calculus. Here's what it comes down to. SpaceX is solving engineering problems. China is scaling production. Right now, SpaceX has the innovation lead. They're years ahead in reusability and operational experience, but China has momentum. They went from 68 launches in 2024 to 88 in 2025, while SpaceX deals with exploding pressure vessels. That gap is closing not through better technology, but through better manufacturing systems. The real competition isn't about who builds the best rocket. It's about who can build the most rockets reliably. SpaceX proved reusable rockets work. China is proving reusable rocket factories work. Both approaches matter. Both will define who controls space access over the next decade. So which one wins? Innovation or industrial scale? Drop your prediction in the comments. If this breakdown was valuable, hit that like button and subscribe to New Space Review. Turn on notifications because Flight 12 is launching soon, and China's mega constellations are coming online fast. This story's just getting started. See you next time.